Hi students, here are your notes for the inverse trigonometric functions. These are those functions like the inverse sine, inverse cosine, inverse tangent we used in the beginning of the term to find angles. So this section, we're going to really focus on those functions. So to get us going, we have to discuss some things that you learned in a previous math class. If you took Math 111 here at PCC, you learned it then. The formal definition for a function is it is a relation where each input has exactly one output. Something you probably were taught, another way to say this is no x is repeated. Remember, you would do the vertical line test to see if a graph met the definition of a function, and that's because you're checking to see if your inputs have been repeated. Remember, some other terminology there is input is your domain, output is your range. The other thing I want to refresh your memory on before we get into the trig functions is how to find the inverse. So you talked about this in a previous math class, and you have this function, f of x equals 1 over x plus 3. Well, I can rewrite that as y equals 1 over x plus 3. Now, what you do for your very first step to find the inverse is you swap out your x's and your y's. So I'm going to just highlight that. So see how my x now goes here and my y goes there. And now you solve for y, because what you're doing when you're finding the inverse is you're swapping your domain and ranges. Hence, you're swapping your x's and your y's. You're swapping your inputs and your outputs. So if I'm going to solve for y there, I'm going to go ahead and rewrite this just to have a little more space right here. I need to go ahead and multiply both sides by that denominator. So now I get x times y plus 3 equals, these reduce out and we get 1. Now there's a couple ways you can do this. You could distribute that x and keep solving for y, or you could realize, wait a minute, if I just divide by x, so now I have y plus 3, because these reduce out, equals 1 over x. Well, y is not quite by itself yet, so I'm going to subtract 3 on both sides. And so you end up getting 1 over x minus 3. If you went ahead and you distributed that x, you could keep solving for y, and what you would have done is you would have ended up with the same thing, except that these two things would have the same denominator. So it would just look a little different, but it's the same exact function. Here's the key thing though, you found the inverse, so you need to let the reader know this is not just y, we just use that as a placeholder. So we want to say the inverse of x, remember that notation, is 1 over x minus 3. Okay, so what happens here is this is an example of a one-to-one function. So a one-to-one function is, all right, so like I just said, it's an example of a one-to-one function. Well, the definition of a one-to-one function, and I'm going to pull up a graph in a moment, but it is no two inputs correspond to the same output. So what that is saying, let me change that. Let me just make this, rate this a little bit better. So what that is saying is no x's repeat and no y's repeat. Let's look at this visually. So let's pull up Desmos and put this in. Y equals, well, the original function was 1 divided by x plus 3. So I'm going to get out of here. So if you're looking here, we can follow that all of our x's, so if we just like were to look at all of these things, they will never have the same output, right? So your x's won't repeat and neither will your y's. Now, what's special about this is one-to-one functions is this means that their inverses are also functions. So knowing that, when you were learning this, you would be given a graph and you would say, is this a function? And you would do that vertical line test. And then you might be asked, is the inverse a function? Well, then you would do that horizontal line test. Well, a one-to-one function means, you know, every input is mapped to a unique output. That means that it's also, their inverse is also a function. Now, we can make things always have inverses. It just doesn't mean or guarantee that the inverse is a function, okay? So these one-to-one functions are really important because, oh my gosh, our inverses are also functions. So it's a little bit easier to work with. So looking at y equals x squared, right? This parabola you've worked with in your past, would you consider this one-to-one? So what I mean by that is, you know, is each input mapped to a unique output? Well, if you look, just like right here, let me change my color. This 1 gets mapped to 1, but -1 also gets mapped to 1. So this is not one-to-one. The other way you could do that is you could do the horizontal line test, if you remember that piece. So it's not one-to-one. However, maybe I could just look at a portion of this graph. So then it could be one-to-one. So what I mean by that is you do have this function y equals x squared, but maybe I don't want to look at the entire thing. I want to restrict the domain. Now that is up to you, right? So I could say, well, I'm just going to look at my domain. So in set builder, I could say x such that x is greater or equal to 0. And so what I mean by that is I am just going to look at this function from here on and totally ignore the other piece. Well, that green highlighted piece is from 0 on in the domain. And that would make it one-to-one, right? Because if I did that horizontal line, when you're ignoring the other part, it is just going to hit it once. So each input would be mapped to a unique output. Just to refresh your memory, or I could use interval notation and say 0 to infinity. Now, some of you out there would be like, but why couldn't I say, I'm just going to look from here on, right? Or just from like 0 to 5. That is all doable, right? We have to kind of agree how to restrict it so then we're all looking at the same pieces of the graph. So we're going to talk about that more in the next video. But, you know, we are just going to agree just to look from x is greater or equal to 0. Some of you might be like, I don't want to include 0. That's also an option. So we're just looking at part of this graph so we could make it one-to-one, because then that guarantees my inverse to be a function.